All right, everybody, we're here to talk about how science can make you a real superpower. But the bad news is I'm not going to give you the gift of flight or X-ray vision because we're not going to break the laws of physics. So no Superman here. But what I can do is think about Captain America or the Black Panther. These are two characters who are known to be near the pinnacle of what the human body can do. And so what we're really asking, I think, is how could science make you better than healthy? And first, I want to tell you a story. In 1995, an 18-year-old high school student, soccer player, comes in to see the doctor in Omaha, Nebraska, and she's complaining of back pain. The doctors find out that she'd been in a car accident 2 years before, and so they were a little worried there might be something wrong. After the car accident, she just had some bruises. She didn't break anything. She was fine, so they ordered an X-ray. It turns out her spine was fine. She just needed a little bit of physical therapy. She's an athlete, and she went on to do her athletics. But they took a look at her X-ray, and they were astounded because her bones were extraordinarily dense. And you can see on the left the very, very thick bones. Bones are the same size, same shape, just super dense. And the scientists got interested, so they said, hey, can your family come in? So her family came in for bone scans. Her parents came in, her siblings, her cousins, her aunts and uncles, and they all had extraordinary dense bones. In fact, their bones were so dense, they were in the top 0.0000001% of humanity. Each one of them was 1 in a million. They never had, nothing bad ever happened to them because they had really dense bones, and none of them could ever remember ever breaking a bone. But they were otherwise quite normal. And so which to me sounds less like medicine and more like the movie Unbreakable. But then what happened was really cool. The scientists asked the family if they would donate their DNA for scientific research, and they analyzed the DNA. And they found out that there was one mutation in one gene that gave these people extraordinary bones. And what even more exciting is that some other scientists found out about that gene and turned it into a medicine that's used for osteoporosis. There's tens of thousands of people who are taking this drug right now. And so they took this observation and extraordinary chemical and found a way to make regular people stronger. All right. So I'm a mechanical engineer. I'm a bioengineer. I'm an expert in biomechanics. And today I'm hoping to explain to you how science fiction should be helping us to make science. And I'm going to share with you an idea that we had about how we could potentially make a superpower, not extra dense bones, but super strong bones as a material. And so next, I want to tell you a little bit about my history. Right, I'm now a professor. But once upon a time, I was a kid, and I was a super big comic book fan. Every Saturday morning, to wake up early morning to take care of all my chores, and then bike into the comic book store to pick up the latest arrivals. I would rush them home, set them out on the living room floor. I'd read them, and then I'd read them again. And I like to think about the questions, well, wasn't it amazing? What if somebody could heal super fast? What if somebody could read minds? What if somebody had unbreakable bones? And a lot of kids think about those things and say, wow, that's a cool story. What a great character. And I was the weird kid who said, well, how could we actually build that? And so that's how I ended up becoming a mechanical engineer and a scientist. That's my origin story as a scientist. But when I became a scientist, part of the job is to stop thinking so much about superpowers and think more about the problems that everyday people experience. And so I didn't think so much about superpowers. For me, I was thinking about osteoporosis and osteoarthritis and injuries. And so I sort of set the fantasy part aside. But 2 years ago, I was preparing a project, planning a project to help people with osteoporosis. And I realized something that only a comic book fan would realize. If I changed one way of doing this project, I would take it from helping make somebody healthy to helping make somebody better than healthy. And I couldn't stop thinking about it. And so I want to share it with you today. But first, I got to explain to you why I think bones are so exciting. First thing I'll tell you is that pound for pound, bones are just as strong as stainless steel. And so if you think about it, it's kind of amazing. You walk every day, you take steps, you jump, you put tremendous loads on your bones, and they're so lightweight, and they manage to pull us off. And the other thing bones do is that the more you exercise, if you start lifting weights, your bones over time will grow to be bigger. Okay? Your bones when you were a kid grew with you, and if you break your bones, they usually heal. And now engineers have been trying to make materials that do that in one of those three things for decades, and we never succeeded. And so I spent a lot of time thinking about how bones break and what is it about them that makes them break. Bones are so strong because they are a complicated material. They have the mineral in it, but they also had organic components. And technically what we call them is a biological composite. And the mineral part are these tiny little nanoscale crystals of the calcium hydroxyapatite. And then those crystals are held together by a network of proteins in your bone. So there's over 100 different proteins that hold those minerals in place. And they're the key parts that stretch and float it so your bone doesn't shatter like glass when it breaks. It brings a little bit more control in a way that can heal. And we know those proteins are important, but we can't study them very well because the technology doesn't allow us. If there's over 100 of them, we're only able to look at one at a time. So imagine if you were trying to bake the world's best cake. You have lots of ingredients, you try and put them together. Imagine just putting them all together, making the cake, tasting it, and then you can't make the next version for another year. How quickly would you get your best recipe? Not very quick. So so that's where we've been with bone biology. We try and study one of those hundreds of different proteins in the bone, and every time we change one, it takes us a couple years to figure out what's going on and move on to the next one. But when I was working on this project, there are three technologies that are really going to change it. And the first is robotics. We have new robotic technology in bioscience that is amazing. This is a bioscience robot at University of California, Berkeley. And what the robot is doing is moving plates of about 100 different human stem cells and editing them. And so you're able to make mutants inside that plate. So from my perspective, I take a plate of 100 cells, put it inside, and 3 weeks later, out pops a different mutant for every clone. And each of those mutants can be a different recipe for making bone. What we do is we take these cells and we turn them into cells that make bone in my lab. So the second thing we do is, if you make that recipe, you want to taste it. If you make a new recipe of bone, you got to figure out how strong it is. And so what we've done in my lab is figure out a way of taking the mutant cells and coaxing them into making bone in the laboratory. So they make tiny little granules of bone. This is what they look like. They're about the size of a grain of sand. Not big enough to replace one of your bones, but big enough to check it out to see how strong it is. And then we take this little grain of bone, we put it into what we call a focused ion beam and drill a perfect little cylinder on the top of it. And then when we have that perfect cylinder, we have nanoscale technologies. I don't have the real one here, but it comes down, it loads up that pillar and shatters it. And then we can figure out how strong it is. So now we have a way of taking hundreds of different recipes for making bone. We have a way of figuring out how strong each of those little recipes is. And then we have the last technology that allows us to take all that data from hundreds or thousands of different mutants. And you guys know what that is? Somebody could say it? Artificial intelligence. We use all of that data to train an AI model, and then we can start asking that model, well, what happens if one of these proteins is gone? How strong should the bone be? What happens if that protein is gone? How strong should the bone be? But this is an AI model. So instead of saying what happens if something's missing, we can ask the AI model, which protein combination, which recipe should we put in to make bone that's better than healthy? What could we do to make a super bone? And once we figure that out, well, no one's gonna, charge out of the laboratory screaming into the Canadian wilderness with super bones on. We have to go through several safety patterns and do the other science. I mean, when somebody works in a peach fish, lots of things they work in a peach fish, but they don't work in a whole living organism. So what we'll do is take a whole living organism, in our case probably a mouse, because we can genetically engineer mice, and we genetically engineer these mice to have super bones, and then grow them up and see. And I think it's probably going to look something like this. And, you take these bone samples and find out if it really works. and then we're able to maybe one day turn this into a medicine. And our goal, like I said before, like that family in Nebraska, is once we do the basic science and the basic genetics to find out what makes a bone really strong, then we can start working on the medicines that we would give to normal people. All right, so I mapped out hypothetically how you make a superpower. You figured out how to make a superpower. What could you do? Cannot tell anybody. You got to try it out. Come on, you got to try it out. So I've started something I'm calling the Unbreakable Initiative at the University of California, San Francisco. Almost all of the work we do at the medical center is about how to make people healthy. Somebody who's not healthy, how to get them to healthy. This is a different kind of science. We're asking the question, how do you get somebody to better than healthy? We think that's because we think it's cool, but we also think it will do great things for people's health. Most scientific funding agencies don't support this kind of work, so we're turning to other individuals. We're looking for teammates. We're looking for comic book fans and science fiction fans because, as history goes along, a lot of times we see things in our movies and our television before we see them in reality. Anybody remember the Star Trek communicators that became the flip phone? Does anybody remember that TV show Knight Rider in the 80s? With the self-driving car and the AI that taught to you? Well, we had that now. It's been 4 years. What might we have 40 years from now if we actually take the time to dream? This is our website. We have a new website and a program through the University of California, San Francisco. I hope you check it out. What I'd like to be able to say at the end of all of this is that if we're able to make the first real superpower, it'll be the comic book fans that made it happen. So join us, follow us on social media, and tell your friends about it. Thank you.